You can see the balloon in the 100-degree F container on the left is swelling up faster and larger than the 70-degree Fs, indicating a lower pressure due to more moisture content. This is a chart I made using EPA data. It's available on the internet. It's large precipitation events, and I combined surface temperature anomalies with it. This is the website location where you can get this data. A lot of data out there from the EPA and NOAA and other sources. What this chart is, it's a percentage of the land area of the contiguous 48 states where a much greater than normal portion of total annual precipitation has come from extreme single-day precipitation events. On this axis, we have percent land area. This is the year. It goes back to about 1910 up to actually all the way up into 2020. On this axis, we have surface temperature anomaly in degrees F. And so the blue lines, or the blue columns here, are individual year data for the percent land area. The solid blue line, let's see if we can point it out there, is a 9-year moving average of that same data. The red line is a surface temperature anomaly. And what I really want to point out is from around 1970 here up to the present, there's been a direct correlation, increasing temperature, increasing giant precipitation events. So I don't know how much clearer that could be to anybody who's wondering if this is really going on. So I highly encourage you to look at some of the government data out there. It's very interesting. A brief description of relative humidity that I got out of Wikipedia. Basically, relative humidity is the ratio, usually expressed in percent, of how much water vapor is in the air and how much water vapor the air could potentially contain at a given temperature. This is why in the summertime, you could get up in the morning, it might be 90 to 100% humidity, 70 degrees F, then warms up during the day. Even though the absolute amount of moisture in the air is about the same, the relative humidity will drop off because it's warmer. And then if it cools down later in the afternoon, that extra moisture in the air condenses out and you get a thunderstorm. Many years ago, I moved from Georgia to Michigan in the wintertime in January. And it didn't take me long to notice that when it was extremely cold outside, which was normal up there, 10 degrees Fahrenheit, 0, one time it was minus 22. Inside the house, it might be 70 degrees F. Well, outside, the weather conditions might be at that extremely low temperature, 50% relative humidity, but inside the house, the relative humidity would drop extremely low. I had actually measured as low as 3% in my house before. It's terrible on drying out skin, static electricity, and so forth. So I started learning a lot about relative humidity, absolute humidity, dew point, how it's all affected by temperature, and so forth. We're not really going to go into that here, but I do want to mention a couple of things. You know, my wife and I live on a farm and we have farm animals, so we're real interested in this. We're interested in the climate science, the meteorology, climatology, and all that. We watch the Weather Channel a lot, and they do a good job of talking about these things. And we monitor it ourselves. And the issue is, if it's 70 degrees and some humidity, let's say 50%, if the temperature warms up suddenly to a higher temperature, say up to 90 degrees, the relative humidity will drop off because the amount of absolute moisture in the air is roughly the same over that short amount of time. But the relative humidity could be a higher number because it can go up. At higher temperatures, you can have more moisture in the air at that temperature than you can at the lower temperature. So the relative humidity is a measure of that fraction, that percentage that can be in the air at any given temperature. So, but the Weather Channel is always talking about how, since there's more moisture in the air, that helps contribute to these gigantic precipitation events. If you look at the government data, they've been going up since 1970, like exponentially. It's just amazing, really. If you go to I think it's NOAA, it's a website. There's several of them. You can look at this sort of thing. And but they're always talking about that's because of the global warming, climate change, which I'm a complete believer in because I understand what's going on with that. So there's more moisture globally. This is a global effect. We're not talking about local things. When we talk about climate change and more moisture in the atmosphere, generally you're talking about the whole world. It's a global thing. So you can have individual little weather events within that global effect, but you definitely have more warming, generally more moisture in the air. So that more moisture content makes it more likely when you have the right weather conditions that you're going to get a major deluge, which we've had here at this place, than you used to when there wasn't as much moisture in the air. So what I decided to do is, can I mimic that or duplicate that in more of a lab type setting? This is not a lab, it's my living room. But I've got these two glass carboys here, and I think that I got them from a home brew place a long time ago. I don't do that, but they were just available in that place for another experiment. I put 500 grams of distilled water in each one of these things. I marked one 70 degrees F and one 100 degrees F. And what I'm going to do is take them into the bathroom and immerse each of them individually into a water bath in a bathtub. Try to control the temperature of one at about 70, the other about 100. And so as soon as I've got that about right, I'm going to let it go for about 10 minutes. And then I'm going to put this balloon, it's got a large balloon here, down inside the neck of this, seal it around the top. And that will give me an idea of how the atmosphere is going in or out of this thing. Do the same thing with 100 degrees F. And see, because water vapor is condensable, oxygen and nitrogen in the atmosphere are not. And so if there's really more moisture in here at 100 degrees F than there is here, this balloon should inflate more. So we'll test that and see if we can demonstrate it with this. And we'll see what happens. So we'll give it a go. I need to point out that since there's 500 grams of distilled water in each of these carboys, the relative humidity in each of these carboys is going to be close to 100% at those temperatures. But the absolute humidity, the amount of moisture, will be greater in the 100 degree F than the 70 degree F carboy. Okay, quick look at how I'm doing this in the bathtub. Got the temperature. This is the 70 degree F one. There's a range. Let's see, there we are. We're actually at 70.9. The 100 degree F one actually ranged from about 99 to 102. But this is pretty uniform. I'm using this cup here to just carefully bathe the exterior of this. Be careful not to get it inside there. And for 10 minutes. That's more of a pain than I thought it would be, but we'll see what happens. Okay, I finished the water bath. 100 degree F's been out here a little bit longer than this one. It's already partially inflated in there. So what we're going to do is go out to the porch. This old house, this old porch needs a little refurbishing. Temperature out here, according to that, it's usually pretty close. It's about 48 degrees Fahrenheit. So what I'm going to do is set each of these carboys down here under this umbrella to keep the rain off of them. Also any sunlight, there's not much today, but we'll shield them from that also. And we'll see what happens. Okay, I've started the timer. This is like some of my other experiments that are about as interesting as watching paint dry. Of course, I'll speed this up. It's been 35 seconds. Pretty good bit of heat capacity in those glass carboys. So it's going to take a while for it all to equilibrate. You can already see one thing. There's a lot more condensation on this 100 degree F one on the top than there is on the 70 degree F one. That's your gigantic rainstorm because there's more moisture in the air. A little hard to see, but there is a good bit of condensation appearing in this 100-degree F one. Virtually none over here in the 70-degree F one. So, balloon's filling up. That one's filling up too, but that one's filling up faster, which I would expect. Okay, it's getting close to 12 minutes. I believe I'm going to go ahead and end this experiment. I think it's already demonstrated what we need to show. We'll go ahead and look at this real quick where any rain comes in here. See all the condensation in there? That does simulate gigantic rainstorm due to more moisture in the atmosphere versus over here at 70 degrees F, virtually none. Look at the balloon here. That simulates a greater lower pressure area compared to over here. Would be more air rushing into that low pressure area causing damage compared to this. Now, one thing we need to do is make sure we compare just simply 100 degrees F with water to 100 degrees F with no moisture vapor in there at all. So what I've got, it's a little hard to see from the camera, but I've got desiccant packs in there, desiccant packs here to allow air to come in and out, but for these to dry it if it tries to go in. So what we're going to do is put both of these in a 100-degree F bath in the bathtub for 10 minutes. And then I'm going to seal both of them with a balloon, put it down into the neck, and then take it outside. It's still pretty cold today. That'll be our cold front, and see how they compare. So we'll go ahead and try that. Okay, we got 100.9 degrees F. What we're doing, this is our one that's got the water in it, this is the one that's dry, and we have a cup over here. Just bathing these things, trying to keep it out of the inside like this. That's going to do this for 10 minutes before we take them and put the balloons in. Okay, today we're reading pretty cold today, about maybe 39 degrees. Okay, we put our carboys out here on the porch, 39 degrees F. This is the dry one, it's desiccated. This is the one that still has 500 grams of water in the bottom of it. And we'll see how the balloons expand. I would expect that one to expand more because it's got condensable water vapor in it, and a fair amount. This is completely dry, so the only thing that can happen here is a contraction of the air itself, just oxygen, nitrogen, just from the atmosphere. There shouldn't be any water vapor in this one, or minimal amount anyway. So we'll give them a few minutes and see what happens. Okay, it's been 10 minutes. Let's see what we've got. This is the carboy that was dried out. See the desiccant packs down there at the bottom. We had desiccant packs up here too. Then I put the balloon there after conditioning to 100 degrees F in that water bath. You can see the balloon is partially inflated, as you would expect, because the air contracted in there due to the lower temperature we're getting to. No condensation because there's no moisture in the air. This one, on the other hand, there's a lot of condensation on there. We'll try to get it where we can see it. A little hard to see, but let me get a flashlight. You could hear our horse Rocky wondering what in the heck is going on up there on that porch. You can see, well, but there's condensation streaming down the sides of this carboy. That's your gigantic rainstorm because there's more moisture content in the air when it's warmed up and it's very humid, and then a cold front comes through. This balloon expanding so much like it is shows you that there's going to be a greater windstorm, greater intensity of the air moving into that low pressure area created in there due to the moisture vapor condensing, compared to the dry one, which is not nearly as inflated, maybe roughly half as much. And so here you wouldn't have a big windstorm. You'd have a breeze and you'd have no rain. Over here, you got a big windstorm and you got a gigantic deluge of rain. So this is what warmer temperatures and more moisture in the atmosphere will do. So I think that pretty well demonstrates it. I hope you enjoyed this. If you did, please like the video and click on the round Anisotropic Plus subscribe button and check out our other links. We'd appreciate it. Thank you.